All right. So here's our cumulus cloud. Okay, notice there's no, well, there's updraft isn't shown, but the fact that we have a little bit of vertical development probably have an updraft. No precipitation, so it's not in its mature stage. But, and it might be kind of hard for you to see, but we have, and I'll put this whole thing up here. What's probably not too hard for you to see is you see these negative charges here, okay? And you see the positive charges within the same cloud. But maybe what you can't see is down here, remember I said your hair standing on end? Down here on the ground, those pluses, actually has been an induction, it's been an induced response to that bottom of that cloud. So the bottom is negative, okay, which basically has caused the earth underneath it to become positively charged. The earth is a great grounder, which means it can actually go either way. It can say, okay, I'll respond and give you basically deficient electrons, or I'll respond and give you electrons. So basically that is your hair standing up on it. So when we talk about lightning, okay, lightning is a discharge of electrons. Now, one of the things, actually, we get lightning in its mature, when the cumulonimbus cloud is in its mature stage. Okay, and that's the updraft and downdraft are not being shown here. But just have to bear with me. There is an updraft and there is a downdraft. Okay, that will give us lightning. And so lightning is basically electrons want to go from where there's too many, negatively charged. In this case, this is that rare 20% type of lightning. So electrons are going to go from the base of the cloud to the ground. Yeah, where there's less electrons. Okay. So actually that's the discharge of electrons. This, I've never used the, not recently anyway, included the term runaway breakdown on your unit exam. But the initial thing is actually called the leader. Does that make sense? I think that makes sense. So that was from the cloud to the ground. I'm going to show you a few other figures that actually, along that same path, is a flow of electrons, like I kind of mentioned, from the ground back up to the cloud. This is ground to cloud lightning, or cloud to ground lightning. I don't know how do you want to do that. So sometimes, have you ever kind of looked at the same lightning stroke and you feel like your eyes are going buggy? You're like, dude, I saw like kind of an assortment of flashes all in the same area. And you're right. So basically you've seen a flow of electrons kind of back and forth between the similar vicinities in the cloud and the ground. So all of those flashes kind of go to give us our one lightning stroke. Okay. So continuing on with kind of what electrons do, after the leader, okay, we can actually, along the same path, get a return stroke. Return stroke from the cloud to the ground. So the difference here is basically the negative part of the cloud is not the base, it's kind of moved up. So this is just kind of the back and forth flow of electrons. Dart leader actually is kind of similar to what we've been talking about. I think of dart leaders as kind of those little kind of fingery sort of things that come off of the main bolt. So again, not a whole lot that I necessarily test you about. One of the videos that I used to show, I don't think it's on the one I want to show you, and we'll look at that on Friday, but it says that lightning is not entirely understood. Thanks. It's just kind of the way it is. Yeah.
It's kind of like tornadoes.
Yeah, tornado.
So much about it.
Yeah, tornadoes. We know so much about it, but there's a lot of things we don't know about tornadoes. Exactly. So lightning is kind of in the same ballpark. It'd send a man to the moon, but no, I'm just kidding. So you have the flow of electrons, and that creates your light part. Okay, we call lightning. And then the audible part, like I was saying, is basically in that vicinity, it's really hot. It's like, what's it, 5 times hotter than the surface of the sun, not the center of the sun, but 5 times hotter than the surface of the sun. And actually, if you've ever heard of, well, we talked about ozone. Ozone's at O3. And so actually, it's so hot that in the vicinity of the lightning bolt, I'll go ahead and change it from cloud to cloud to cloud to ground lightning. In the vicinity of that, actually, it will create ozone from the nitrogen, from the oxygen in the air. And ozone has a certain smell to it. So like, interesting. Have you ever heard of like lightning hits like on a sandy beach, where actually we'll take the quartz, yeah, and fuse it together? Anyway, that's on my bucket list. After the lightning passes. Okay, so I think you're okay with that. So this whole kind of kaboom after you see the lightning, the thunder part, actually is a sonic boom, because the air is expanding faster than the speed of sound. So the thing about sound is that it travels slower than light, okay? So that's why you will see the light from the lightning, and then you'll hear the thunder, okay? Because sound is slower than light. And so you may have grown up with this old adage, where this old adage, you know, I learned it as 5 second, the 5 second rule. Not that if you drop something, it's okay, but it's the other 5 second rule, that you count the delay between seeing it and hearing it. And for every 5 seconds, it's a mile. Yeah. So if it's 10 seconds, it's 2 miles.
Right.
Right. If it's 1 second, it's 1/5 of a mile. Right. So. Yeah. And then there's this thing called heat lightning, which coincidentally kind of reminds me of sheet lightning we talked about a minute ago. Yeah. So the heat lightning doesn't have to be sheet lightning, but if you've ever experienced heat lightning, it's the one that you don't hear. You just see it in distant clouds. And so to me, distant clouds are the ones you're not going to see that 20%. You're going to see that kind of sheet lightning, the kind of the glowing. And the reason you don't hear it is because it's too far away. The sound dissipates before it gets to us. That's heat lightning. Then we have kind of a couple different qualities of the kabooms, a couple different qualities of the thunder. We have kind of a sharp, okay? Then we have that, okay? And actually that has to do a little bit with its distance too. The thunderclap is when it's really close, and the reason the rolling thunder happens is because it basically is echoing off of other stuff. Okay, so they're both kind of cool, kind of creepy. All right. So that's as far as I wanted to get today. I think what we'll do on Friday is it's about, I think, a 15-minute segment I want to show you on thunderstorms and lightning, and then we'll finish up tornadoes on Friday. Okay? Hopefully we will have tornadoes on Friday. And that will make the homework due on Monday.